Hey guys, welcome to week 6. This week's lecture is going to be short because a lot of this is best shown in person in a Teams meeting, walking you through step by step how to do these calculations. So I would highly suggest paying attention to office hours, and if you can't hop on during those times, then setting up a meeting with me at a time that you are able to work on some problems with me. I will utilize Paint on my smaller computer to be able to sort of walk you through drawing those out in live time so that you don't have to look at a piece of paper and try to figure out everything when it's already on the paper. So first, there are two methods for figuring out dosages, right? The first one is a proportion, and that's where you're setting up an equation, basically, where you're saying some known quantity equals some unknown quantity, and you have to solve for x. This involves algebra, cross multiplication, and division, and once you get the hang of it, it's actually really easy to do and works well for any calculation that involves something with volume. So for example, 250 milligrams per 5 mLs would be great to use in a proportion if you're trying to figure out how you're going to give 400 milligrams, which is actually a problem on our homework. The formula method is a little bit simpler, and it works for your answer being your desired over what you have on hand. I also call D what you need, and you divide that by what you have. So in this case, I want to be able to walk you through one of these problems, and maybe I'll take us to the homework in a minute, but let's get through the rest of this, the last slide, and then we'll talk a little bit more about that. I highly recommend that you run through all the problems in the reading, all the problems that are available to you in the book, as well as the homework, and if you need more, please let me know, and I'd be happy to come up with some more for you to answer. So, body weight and body surface area are most often used in pediatric dosing, and that is because we can't simply dose them the same way we would do adults, so we need to use something that is relevant to them, and that's usually as they grow, they get bigger, and as they grow, they get a higher body surface area. So, dosages based on weight are often expressed in milligrams per kilogram, and that might be milligrams per kilogram per day, milligrams per kilogram per dose, so just pay attention to that part after the milligrams per kilogram. So the first thing you're going to need to do whenever you come across a problem that involves milligrams per kilogram is convert the patient's weight from pounds to kilogram, and again we do that by dividing by 2.2 pounds per kilogram. So if I weigh 70 kilos, or I'm sorry, if I weigh 150 pounds, I would divide by 2.2 to get my weight in kilograms. The next thing you would do is multiply the number of milligrams per kilogram that the dose is looking for, and then you would multiply that by the weight. So if you had a child that needed 30 milligrams per kilogram per day, and you had a 30 kilogram child, you would multiply 30 milligrams per kilogram per day times 30 kilograms, and you would get 900 milligrams per day. Dosages based on body surface area are used to calculate very precise medication dosages. So a nomogram is a set of scales arranged so that a ruler aligned with the two of the values show the corresponding value on the third scale. So for example, weight and height, and you draw a line between the two, and you'll come up with a body surface area in the middle. So that pretty much covers that. I want to take you over to the homework. Might take me a minute to get logged in, but I want to be able to walk you through a couple different problems. Again, not the best situation, not being able to draw, which is why this lecture actually took a little bit of extra time, because I was hoping that I could draw on my screen for you, but my other computer wasn't allowing it to upload to YouTube, which is where I put all of these lectures. So we're going to go back. We're going to go into your homework for week 6. Gonna give it a little preview, and this first question's multiple choice. The second one's where it starts to get fun, right? So watch the video. Always watch as much as you can to learn how to do this. And what it's telling you is calculate the amount to administer using the formula method. And this isn't necessarily a proportion method, but we did say that it might be a good idea to use the proportion method when we have a volume, such as 250 milligrams per 5 mLs. So what you have ordered or what you need is 400 milligrams every day. So the question is, what are you going to give this patient if you know you have 250 milligrams for 5 mLs? So there's a couple different ways you could go about this. You could set this up as a proportion or a ratio, and you would put 250 milligrams over 5 mLs is equal to 400 milligrams over X mLs, and what you're solving for is X. You would cross multiply and divide, so 250 milligrams times X mLs equals 400 milligrams times 5 mLs. You would multiply the 400 by 5, which would give you 2,000, and now you've got 250 milligrams times X mLs is equal to 2,000 milligrams times mLs. You would then divide each side by 250 to get X alone, because that's what we're solving for, and you would cancel out your 250 on the left, and on the right you would have 2,000 divided by 250, and it should come out to be 8, and your unit is going to be mLs because your milligrams have canceled. So the answer to this one using the rate of the proportion method would be 8 mLs. If you use the formula method, you're going to divide what you have by you're going to divide what you need by what you have. So what you need is 400 milligrams. Now what you have on the bottom is going to end up being sort of needing to be divided anyway. In this case, we would take 250 milligrams per 5 mLs and divide that 250 by 5 to tell you how many milligrams are in 1 ml. So 250 divided by 5 is 50. So you've got 50 milligrams in 1 ml. Now, we can take that what we have and basically put it on the bottom of our equation and divide what we need by what we have. So 400 milligrams is what we need, divided by 50 milligrams is equal to 8 mLs. All right, so that's 50 milligrams per ml. So hopefully that one makes a little bit of sense to you. I want you guys to walk through the rest of these and let me know if you have any questions. Again, we can always hop online and draw them out on Teams. Another one where I find that the formula method is more appropriate is when you're dealing with tablets. So let's take number 5, for example. You have received an order to give a patient 650 milligrams of acetaminophen. When you obtain the medicine from the cabinet, you see that each tablet is 325 milligrams, and the bottle originally contained 200 tablets. Your calculation shows that you should give X number of tablets for the correct dose. So, ignore that 200. It doesn't matter to this question. What they want to know is how many tablets are you going to hand this patient for this dose? You need 650. You have 325 milligram tablets. So, you would divide what you need, 650 milligrams, by 325 milligrams per tablet. This should give you 2, and you would give 2 tablets. Again, if you guys have any questions about this, please always feel free to reach out by email, or we can set up a Teams appointment. I'm more than happy to help you out there. I hope you guys have a great week 6, and I'll talk to you soon.